All right, let's make the key for the chapter test that we had. So, as I said in class, some of you may have thought that I was putting on all these problems to be tricky, but I'm not about math being tricky. I'm about putting problems on that have the common mistakes that students make when they move on in mathematics, and those common mistakes cause them to get things wrong when they really understand the concepts. They just don't get the algebra stuff kind of right. And so, for example, in this first problem, it looks really nice to try just do 5 minus 3 right away, but there's multiplication here. That has to come before this subtraction happens, order of operations. And there's a power. And a common mistake is if they're subtraction, students want to distribute powers, but they can't be distributed over subtraction or addition. So you need to do in the parentheses first, and there is multiplication and subtraction. Multiplication comes first, so this be just writing stuff down. And I know you get anxious. I know what 5 minus 3 is. Well, you don't get to do that now. And this problem isn't about 5 minus 3. It's 12 minus 10 squared, and you can't distribute the power, so it's not 144 and 100. It's 12 minus 10, which is 2 squared. And that's times 3. And it's still tempting to do that subtraction, but this is multiplication. You got to do it first. You got to do the power before that. And 2 squared is 4, so we got 5 minus 3 times 4, and this multiplication has to come before that subtraction. So that subtraction is hanging around, and tempting you to do it right away. But we have 5 minus 12, which is negative 7. Very similarly, this 2 plus 3 is very, very tempting to do right away. But this 3 is times this quantity, so we got to take care of what's in here if we can. And it's tempting to go 3 minus 1 is 2 times, and 18 divided by 2 is 9. But no, division comes before subtraction. So we got to do 18 divided by 3 first. And then we have to do this before the 3, or the exception to the rule would be to distribute the 3 to this. You can distribute a number that's times, but you cannot distribute a power. So you get 2 plus, and this is 6 minus 1 is 5, so 3 times 5. And it's still tempting to go 3 times 5 first, 3 plus 5 first, 2 plus 3 first. But times comes before addition, so 3 times 5 is 15. And finally, we get to do the 2 plus, but it's to 15, which makes 17. So I'm putting this out here as bait. Will you do that addition or subtraction before you do the multiplication? And many of you bit on that error that's commonly done by math students. Okay, 2a. Powers like this really confuse students. And so don't be surprised that you were confused by it. Now, I'll just look at this first part here. There's no power on the outside, so I can just look at this and say that's 25 x 6 y to the minus 2, and I can leave it like that if we want. And this part, this is all multiplication in here, so I can distribute the power. Up here there was subtraction, which prevented me distributing the power, but I can here. Now we got to distribute the power correctly. This is 5 to the 1 power, understood 1. So when we distribute the power, we've got 5 to the 1 to the minus 2. And when we got something to a power, you don't add powers. A lot of you added minus 2 to each of these. You multiply. So minus 2 times 1 is 5 to the negative 2. Negative 2 times 3 is negative 6. And negative 2 times negative 2 is y to the plus 4. Now we're multiplying. That's when you add powers. Here we got powers to powers. That's when you multiply powers. But now when you multiply, you add the powers. So you can think of 25 as 5 squared. So 5 squared and 5 to the minus 2 is going to be 5 to the 0. Or you can think of minus 2 means put it in the denominator as 5 to the plus 2. So 25 divided by 25 is 1. Or if you thought 5 to the 2 times 5 to the minus 2, you get 5. You add the powers, you get 5 to the 0. And some of you do not know that 5 to the 0 is 1, because this really is saying 25. Put that in the denominator, 25, and 25 divided by 25 is 1. A number to the 0 power is 1. So this is 1. This reduces with this, 25 over 25 is 1. Now we got x to the 6th, and this puts an x to the 6th in the denominator, which means it's going to be x to the 0. We add the powers, and x to the 0 is also 1. So x to the 6th over x to the 6th, or x to the 6 minus 6, adding the powers, we get x to the 0, which is 1. 5 to the 0, which is 1. Y to the 2. Minus 2 plus 4 is 2. So this is simply y squared. Now that's one way to do this problem, and probably the easiest way to do the problem. But you could also do it this way. Think of this as 25 x to the 6th, and that's y to the minus 2, so you could move it to the denominator to make it y to the plus 2. The minus 2 as a power of 5 puts the 5 to the 2 in the denominator. Be 5 to the negative 2, which makes it 5 squared, plus 2 in the denominator. X to the 3rd moved to the denominator makes x, and squared is x cubed times x cubed is x to the 6th. And y to the minus 2 puts it down in the denominator, but if you take it to a minus 2 again, that moves it up and squares it, so it becomes y to the 4. Same thing you get if you multiply these two powers, and you get y to the plus 4. So 5 squared is 25. X to the 6th into x to the 6th is a 1. And y to the 4th over y squared, y to the 4th, y squared. These two cancel those two, so basically we're reducing 4y's down to 2y's, and we get y squared. Okay, so here, negative 2 to the 3rd, that's negative 2 times negative 2, which is plus 4, times negative 2 is negative 8. And I'll just write the rest of it. And then if I just use the power rule for powers, bases with powers, in a division problem, we subtract powers. But the negative here isn't a power. So we have a negative number divided by a negative number. The answer is positive. 8 divided by 4 is 2. And if I subtract the x to the third, when I got this, I subtract exponents, so I can do minus 2 minus 3, which would be x to the minus 5. And 3 minus 1 is y to the 2. But I don't like there. I wanted positive exponents, so that would move that x to the minus 5 into the denominator. Or we could have just originally said this reduces to plus 2, and 3 minus a minus 2 plus 2 makes x to the 5th. And since this is smaller, I'll subtract it from there, and I get y to the 2. Okay, 4. This says that's a plus 3, so that means I'm multiplying by 10 3 times. Well, if I take 4.30 and multiply by 10 once, this becomes 43.0. But if I multiply again by 10, I get 430. That's twice I've multiplied by 10, and then I got to multiply by 10 once more. So that's the answer. So this scientific notation, you got to put the decimal after the first non-zero digit. So we're going to write 3.52. Now this number is bigger than what we started with, but it's supposed to be the same number. To make a bigger number smaller, when multiplying by 10, we got to actually divide by 10. So the power's got to be negative. And every time I divide by 10, this decimal moves once. So divide by 10 once. It's here, so divide by 10 once, twice. So I got to divide by 10 2 times. Now, putting the decimal after the first non-zero digit would be 2.7. But 2.7 is way smaller than that, so I'm going to have to multiply by 10 positive number times. So I'm writing it here, but I want it clear over here. So if I multiply by 10, it becomes 27. 270, so I have to multiply by 10 once, twice, 3, 4, 5, 6, 7 times. Okay, now they get a little bit more complicated. 28 times 9.2. So I'm going to pull out my calculator, if I can find it, and do that multiplication. Should have been prepared on this, but got it now. 29 times 9.2. So that's 266.8, and that's times 10 to the 2. But I got to do scientific notation, which means I got to get this decimal to there. So the answer is going to be 2.668. But this number is smaller than that. To make this number equal that, it would have to be times 10 twice to move this 2 places to there. But it's already times 10 twice. So we have to write 2.668 times 10, and when we multiply, we add the powers, we get 4. And now it's in scientific notation. So here, we're going to do 1.32 divided by 7, and that's 0.18857, 0.1886, roundish off. Okay? And this is times 10 to the minus 2. Now, I need this in scientific notation, which is going to be 1.88 1 because I got to move it to the to the right of the first non-zero digit. So it's got to be here. This number is bigger than that. So to make this one smaller, I have to divide by 10. And I only need to move it one place to get it in the right place. And then we still had this times 10 to the minus 2. So it's 1.881 times 10. We're multiplying, so we add the powers. Minus 1 and a minus 2 make minus 3. Okay. Now I'm going to do each of these a couple of ways. First of all, I apologize that the math type program I had makes this 3 look like it's on the X instead of in here. It's closer to being in there, and that's where it's meant to be. This is supposed to be 5 times X cube root of 48X to the 6th. Now, some of you knew the cube root means the 1/3 power, so some of you did it this way. Said 5 and X. You thought about 48 and said 48 is 2 times 24. 24 is 2 times 12. 12 is 2 times 6. And 6 is 2 times 3. Let's check. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. Times 3 is 48. X to the 6th. And we're doing the 1/3 power. So we got 5x, 2 to the 1, 2, 3, 4, a 3, understood 1 power, and x to the 6th power to the 1/3. This is all multiplication, so I can distribute the 1/3 times each of the powers. So I got 5x. 4 times 1/3 is 4/3. 3 to the 1 times 1/3 is 1 times 1/3 is 1/3. And x to the 6 times 1/3 is 6/3. So this is 5x 4/3. You should know as 2 to the 1 and 1/3. And x to the 6 divided by 3 is 2. Now, 1 and 1/3, that's 5x. 2 to the 1 and 2 to the 1/3. When you multiply, you add the powers, so that's 1 plus 1/3 is what 1 and 1/3 is. So these have a 1/3 on them, so they're still under a cube root. 2 and a 3, so that's 6. And there's no 1/3 powers on any of these, so those are all outside of the cube root. 5 times 2 is 10. And x times x times x is x to the 3rd. So there's the answer. Now I'm going to do it the other way I showed in class. So I got 5x and cube root 48. 48 is 2 to the 4th. 2, 2, 2, 2, and a 3. And x 6 times multiplied. And this means we need groups of 3. The cube root of 2 times 2 times The cube root of 8 is 2, so that'll come out as a 2. Cube root of x to the third is an x. The cube root of x to the third is an x. So we have 5 times 2 times, there's an x here already, and then I'm pulling out another x and another x. These three come out as an x because we're groups of 3. And what didn't I get to pull out? Well, there's a singleton 2 and a singleton 3, so I got cube root of 6. So I got 10x to the third cubed root of 6. Not sure which way you like best. Probably neither, but I'm trying to help you see it. Now this one turns out to be easier to do this method. 35 is 5 times 7. Square root, so I'm looking for not triplets but pairs. 32 is 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32. It's 2 to the fifth is 32. And then we got x, 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 x. That's 6, 7, 8, 9 of them. Over 14, which is 2 times 7. That looks like 27. 2 times 7. And there's an x out here. Then we got the square root of 2 times 2 is 4 times 2 is 8 times x. Now, these things are outside, so I can reduce those right away. That's 7, cancel that 7. So I've got a 5 and a 2x, and both of these are square roots, so I can write it as one big square root. 5, 1, 2, 3, 4, 5, 6, 7, 8, 9 over 2, 2, 2, x. 2 over 2 is 1, 2 over 2 is 1, 2 over 2 is 1, or 8 over 8 is 1, and an x over an x is 1. So I have, and now I've gotten rid of everything in the denominator, so it's got a denominator 1 now. And now I got to look for pairs because I'm doing square root. Got a pair of 2's. So I got 5 over 2x. The pair of 2's come out as a 2. And that x we canceled. That pair comes out as an x. That pair comes out as an x. Another x and another x. So I got 4 x's. So the 2's cancel. 2 over 2 is 1. And an x will cancel one of the x's, or 1 from 4 is 3. So I get 5x to the third. $20 is 2 times 10, which is 2 times 5. And that's under square root, so I'm looking for pairs. Pair of 2's is a 2, so I got 2 times 3. And there's a 5 doesn't break down, x doesn't, so I got plus 2 of these. This says add, so there's no multiplication going on here. It says add these two. 6 of those things, and that looks exactly like that. So 6 of whatever this number is plus 2 of whatever this number is makes 8 of whatever that number is. So 64 is 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. 1, 2, 3, 4, 5, 6. 64 is 2 to the 6th, x to the 8th, y to the 3rd. These are all times, so I can distribute the 1/5. 1/5 times 6 is 6/5. 1/5 times 8 is 8/5. 1/5 times 3 is 3/5. 2 to the 6/5, that's 2 to the 1 and 1/5. That's 6/5. X to the 8/5, that's x to the 1 and 3/5. And y to the 3/5, that's a proper fraction. So this was improper, so we changed it to a mix. Improper, so we changed it to a mix. 2 to the 1 and 1/5 is 2 to the 1 times 5th root is 1/5 means the 5th root of 2. This is this. This is x to the 1 and x to the 3/5, 5th root of x to the 3rd, 3/5. And we got y, 5th root 3 times. So I got some things inside the 5th root, a 2, x to the 3rd, y to the 3rd. So inside the 5th root, I've got 2x to the 3rd, y to the 3rd. Outside, I have 2 and an x, and that's it. Okay. Now, I kind of tried to explain this in class once, and it's still not clicking for some of you. But just so you understand why degree is important and leading coefficient, you're going to learn that y equal x is a line. You may know that already. And y equals x squared, you may know that's a parabola. And when it's squared, both ends are going up. When it's x to the 1, one end goes down and one end goes up. If it's y equal x to the 3rd, that means one end is going to go up and the other is going to go down. And so what happens as x gets farther and farther from 0 will depend on the highest power. Another way to explain that is if x was out here at 10, x would be 10, x squared is 100, x to the 3rd is 1,000. The x to the 3rd is way more powerful than x or x squared. 10 times more powerful, 100 times more powerful. So it's going to force, even if you have some stuff in here trying to make things happen around 0, it's eventually x to the 3rd has to go up on this side, and negative number to the 3rd would be negative go down. So the higher the power, the more it influences what happens as you get away from 0. So the highest power here is 5. And that's why they want you to know what the degree of this is. It's going to look like x to the 5th with some wiggling in it when you graph it. And how many of those also controls how powerful that term is. Since there's 2 of them, we want to note that number. So that's called the leading coefficient, the number that tells us how many of the most powerful values of x is. And so the power shows up when you move away from 0. And so the term that's going to control that is the 2x to the 5th. Now, if you move in closer, like putting in a 0.1 to the 5th is 0.00001. Near zero, this thing is tiny. This is tiny. This then is only x 0.1 squared is 0.01. That's much bigger than that, and this becomes the more powerful near zero. So over here, the degree is not 2, it's not 0, it's 3. How many x to the thirds we have? -4. That's the leading coefficient. That negative is telling us it's going to be upside down. 4 means it's stretched, and we're going to be talking about that, but that 4 becomes real important. So, but the power near zero is the one with the least exponent, which is this one, that 1. At 0, this is 0, that's 0, and that's 1. And far from 0, this guy controls, the one with the highest power, so it's -4x third. That's the one that's control what's going on. Okay, back to what trips up students all the time in later courses. It says subtract everything here. And some people don't like, because of that parenthesis and that negative, they don't think of subtract everything. They say, oh, it says subtract, but I'm just going to subtract that one and then I'll just leave these alone. And that's not what it says to do. Now, there's nothing times any of these, so we just leave these alone. But it says subtract a positive 8x, so that's going to be subtract 8x. This says subtract a negative, subtract, which means add 5x squareds. It says subtract, so that's add a 5. And this is subtract a positive, so it's subtract 3x to the third. Now, we've taken care of that minus, which, again, is what messes up a lot of students. Now we combine like terms, which means they have to be the same power of x. Remember, x could be any number, like 7. Well, x squared then is 49, x is 7, x to the third is whatever 7 times 7 times 7 is. This is a much different number than that, but different than that. So you only can add together, if you got 7 of the 49s, or x squareds, it can be combined with the 5 of the 49s. So 7 of them, 5 of them, that's 12x squareds. But we usually start with the highest exponent. We got subtract 3x cubes and subtract 3 more, so that's minus 6x cubed. So we got 6x cubes, 12x squareds. How many x's? 15 minus 8. I think that is plus 7 x's. And then we have this plus 5. A lot of you had minus 5 and minus 7 because you didn't look at that minus going through and changing things, signs of things. Now here, this 3x is times just this quantity. That's what the parentheses say. Take the 3x just times these, not times that. And this says add, so we're not going to take this answer times any of that. It's just going to add, combine like terms. But here we got to multiply first. So 3 times x times 5 is, 3 times 5 is 15 and an x. This is 3 times negative 2 and x times an x. A lot of you didn't put x squared on that. Now, there's parentheses here, but there don't need to be because there's not a minus and there's not any number on the front or back that's being multiplied by all this. So we can just drop the parentheses. And then we usually look for the highest degree polynomial. That's why we kind of call it the leading coefficient up here. It's going to be in the first place. And this is going to be x cubes, and there's minus 1x cubed. You don't have to put the 1 in there. And then we look at x squareds. We've got minus 6 of them, plus 7 of them, plus, that's the only x squared. So minus 6 plus 7 is plus 1x squared. You don't have to put the 1, because 1 times anything is just it. So we've got this combined with this. We got that taken care of. So we got 15 x's plus 1 more. And they're not multiplying, so don't add the powers. It just stays the same. Okay, next page. Multiply these and then sketch an area model. So we got to take 2x. We got to take this times both of these. We spent quite a bit of time showing that. And this times both of these. So there's 4 products. 2x times x is 2x squared. X times x is x squared. 2x times 3 is 6x. 1 times x is 1x. And 1 times 3 is 3. And if you combine like terms, you get 2x squared plus 7x plus 3. But whenever you multiply a number times a number, you're finding the area of a rectangle. So I'm going to make a rectangle that is 2 x's. Now we don't know how big x is, so I'm going to make it that long, an x, and then another x, same length, so that's x and x. That's 2 x's long, and then one more. So I'm going to make one look like that size. The other direction is x, so this should look the same length as that. And then 3 ones. I made one that long, so I got to go 1, 2, 3. So this is supposed to look like 3. Oops, off the paper. X and x, those are both the same length. That's the same length. And now I'm going to connect the lines, make my rectangle. So that was 1, and that's 3, or 1, 1, and 1. So x times x is x squared. 1 times x is x. 1 times x is x. 1 times x is x, or this is 3x. And again, this is x, x, and x. 1 times x. This one is x times x, which is x squared. X times 1 is x. 1 times 1 is 1, 1, 1. So we have 2 squares, x squares. We have 3 6x's and 1x, making 1, 2, 3, 4, 5, 6, 7 x's. And then we got a 1, 2, 3. So you can see by splitting this rectangle up that's multiplied 2x plus 1 times x plus 3 ones. We can get this answer by doing this, but we can also get the answer by looking at this. 2x squared plus 7x's plus 3. Okay. Now, what a lot of students do, and a lot of you did on this test, is take the 3x times this but you also took it times this. But when you multiply, you take the first two and multiply them, take that answer times this. So 3x times 2 is 6x squared. 3x times 5 is plus 15x. And we've got to take that times x minus 1. So now we've got binomial times binomial. You'll take the first times the first. 6x squared times x is 6x 1 power of 2 power of 1. You add the powers, you get x to the 3, or x times x times x. 6x squared times negative 1 is negative 6x squared. 15x times x is plus 15x squared. And 15x times a minus 1 is minus 15x. This is the only x cubed. That's my highest power, so I'll start with it. I got some x squareds here and some here. I got minus 6 of them plus 15 of them. The powers don't change when you're adding, only when you multiply. So we got minus 6 plus 15, which is plus 9x squareds. 15 minus 6 is 9. Minus 15x. So here we've got this whole quantity times this whole quantity, so I got to take this times each one of these. So 5x squared times an x squared. We're multiplying, so we do add the powers. 5x to the 4th. We're multiplying, so we do add the powers. 5x to the 2 plus 1, x to the 3. 5x squared times 3 is, there's no x power here, so we just stay with the 2. 5 times 3 is 15x squared. Minus 2 times x squared is minus 2x squared. Minus 2 times x is minus 2x. And minus 2 times 3 is minus 6. Combining like terms, there's my highest power. X to the thirds, only this one. X to the seconds, I got plus 15, subtract 2, so that's plus 13x squareds. This is my only x term, minus 2 of them, and minus 6. None of those can be combined, because x to the 4th is a different number than x to the 3rd. Think again, if x was 10, 10 times 10 4 times is 10,000, where 10 3 times is only 1,000. 5 10,000s plus 5 1,000s can't be added together unless you know for sure what x is. All right, final page. Got to wrap this up because I got to leave here real quickly. So, on this page, a lot of you forgot to do the first step of factoring. Now, there's not several things to take something out of, but 15 is 3 times 5 times x. Here we got 2 parts to this binomial, and there's something that goes into both parts, and that happens to be a 3. And 3 times x makes 3x, and 3 times negative 5 would make negative 15. Now, you can't cancel when they're added or subtracted to something else unless it all looks the same. There's no x minus 5 up here, so the x minus 5 cannot be reduced. This 5 can't go in there and cancel just part of this. So, but the 3 and the 3, that's a whole thing that's multiplied. Those can cancel. So the answer to this problem is simply 5x over x minus 5. Nothing more to do to that one. Now this says divide, so we've got 8x squared minus 18 divided by 4x to the third plus 12x squared plus 9. First step of factoring, which some of you forgot to do. Is there a number or an x's that go into both of these? Well, 8 is divisible by 2 and 4 and 8. 18 is divisible by 2 and 9. So there's a 2 in both of these. So we can pull a 2 out and we'd have 4x squared minus 9. In the denominator, 2 and goes into that. 2, 3, and 4 goes in that, but only 3 goes in this. No 3 goes into this, and no 2 goes into that, so there's no number that comes out. But there was, oh, I missed it. There's an x. There's an x in this, 3 of them. There's 2 of them, but there's only 1 here. So if we pull out an x, we can only pull out 1, because that would leave that one with none. So this would change to 4x squared, because x times 4x squared is 4x to the third. And this would become plus 12x, and this would become plus 9, because x times this makes that, x times that makes that, and x times that makes that. Now we go to the strips, or however you factor. The number of x's in here is 0, so on my strips I'd be lining up 0 with 0, and I want to get minus 36, so I have to go, one of them is minus, so if I go minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, the other one's got to go plus 1, 2, 3, 4, 5, 6, 7. They all add up to be 0 x's. And do I get anything that multiplies to be minus 36? And I think they're right there. So I have 2 x minus plus 6 and x minus 6. But I need 4x squared, so I need a 2. So I'm going to borrow the 2 from here, divide out a 2, and make this a 3. And I need another 2, and I can get another 2 from here, dividing that by 2 and putting it over here. So this is still 6x, and this is still negative 6x, making no x's, but I get 4x squared minus 9. Down here I have x. This time I got to line up 12 with the 0. 0 and 12, and I want plus 36. So I'm going to go to where they're both plus. So I'm going to add 1, that'll make this plus, and that'll make this 11, 2, 10, 3, 9, 4, 8, 5, 7, 6. There's the 36. So I got x plus 6, x plus 6, but I need 4, so I'm going to divide this by 2 and leave it a 3 and put the 2 over there, so this is still 6x. And then divide this by 2 and leave it a 3 and put the 2 over there, so now I got 4x squared, and I've got 6x, and 6x is 12x, and 3 times 3 is 9. Now, 2x plus 3, 2x plus 3. Oh, there's one there. That'll cancel one of those. This x can't cancel that. The 2, so everything else stays. 2x minus 3, and x, and 2x plus 3. If you want, you can multiply this in and call it 4x minus 6 over 2x squared plus 3x. Multiply the x in and multiply the 2 in. But this would have been my preferred answer. But both are right. Now here, this says subtract, and some people said, no, I'm going to multiply it. No, it says subtract. It's 5x, and just like problem one, or one of the problems, we got a minus, we got to subtract this, and we got to subtract that. And this looks like something that nothing comes out, but the factoring says we got to line up 1 with 0 and keep them adding to be 1. So if I got to get -6, so if I make this go negative, like -1 and -2, and they got to add to be 1, this has to be 2 and 3, and there is -6. So it's x plus 3, x minus 2. Here we have 5x's minus 4x's. That's a simple x, 1x. 5 of them minus 4 of them is 1 of them, minus 2. Oh, x minus 2 cancels x minus 2. We got an x plus 3 left, and a lot of you wrote x plus 3, but it's in the denominator, so we have to put something to hold the numerator, and that would be a 1. So there's the answer.